Let's take a look at waterproofing now. So the main components to this guy is we're going to take a film canister and then we're going to put a transducer, whether it be the piezoelectric buzzer or the microphone, place on the inside, fill it with mineral oil, and then cap it off, right, with the attachment, with our lead coming out. So first off, let's take a look at the speaker. So all you're going to do is you're going to take your piezo speaker, and you'll take your hot glue and you'll put a bunch down in here, place it, right? You don't need to do anything on the outside, just make sure that anywhere where there might be holes or gaps, you cover that in lots of hot glue. The one that I've done here that we use later on in the video, I just mounted it here to the back, right, and then covered it in oil, and then put a hole into the side, covered this all in lots of hot glue so that none of the water comes in, and then you have your leads coming out. And then you've got your waterproofed speaker. Now with the microphone, what you'll do is there's two ways to do it. So this is the smaller amplifier, right, that's very much reduced from our the amplifier that we build ourselves. This guy, you can just cover the whole thing in hot glue again. So I've done that here on this one. And you cover everything but the outside, right, the front of the microphone, so that that's free to vibrate and give you your signal. And again, you cut a hole, put lots of glue in the connection, hot glue in the connection, so that it's well sealed and waterproof, so that water won't get in. And then the other way to do it, if you build your own amplifier, which I recommend so that the whole thing's not out underwater, is you can just take a microphone and get your attachment of your wire and then run that out onto this end, and then what you'll do with the hot glue is you'll actually kind of build up a case for it so that it's directed towards the end, right? If you just left like a tiny bit of glue around the edge, then it might direct down towards the side or something, but you want it to be out towards the end so that it picks up a clear signal. So that's what you do there, and then again cut a hole in the top and place it through. Now you choose to use coaxial cable because it's shielded. You don't want to have your wiring pick up a bunch of stray signals. If you look at what the commercial people do, so this is an actual transducer that you find in like your Garmin or something, is they have this thicker cable with shielding around the end in their leads. They also use a ceramic transducer, which is very much more sensitive and would potentially give you a better signal. So quickly with the coaxial cable, what you would do is you would just chop off the end of it, and we're left with our shielding. Then we can just kind of unravel this up to however far we want it to be. This is going to be your ground, so you can just kind of coil this out like so, right? And that'll be your ground. And then you just take off some of the plastic here on this end, and that'll give you the lead to go into your amplifier, right? Or if you're looking on putting it onto your microphone, then you would connect the two ends here, right? One to your this end here into one end of your microphone and the ground to the other, and that way you'd have both ends connected. And that is everything for the waterproofing. Alright, so what we're going to do first here is we're going to test out our piezo buzzer, see if it's working in the waterproofed housing. So we've got our buzzer here, and what we're going to do to drive the speaker is we're going to use this wave generator. Now a couple of things that we'll want to do on the wave generator is we can set how often it's going to beep. So hertz, right, it'll beep 6 times per second. 8 seems to work pretty well for this setup. And then duty cycle, so that's how long the signal will be on, we'll just set that to about 60% is good, so it'll be on 60% of the time. And so we'll go back to here. Now the output of the wave generator is coming into the back of this stereo amplifier here. So if we just spin this around, our input's coming in here, and then the output, so this is what's going to go to our speaker, we've just connected up into here. So to make it start going, you just hit output here on the channel 1, and it starts beeping. So our speaker is functioning and we're ready to go. Alright, so now we have our whole system here. We're going to take a look at our microphone here on the left and our speaker on the right. You can hear the buzzer buzzing away, beep, 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 Old Faithful. Now, what we want to do is we want to record these signals, right? We want to see what they're actually doing. So we're going to use a software called LabVIEW. On the left, we've got a DAC generator command. It's basically just telling the computer to read in the signals. And on the right, we have a write to file, so that we can look at it later. Now, this is the box that's basically bringing in all the signals. We've got two cables running off of it. Channel 1, which is going to be hooked up to our mic, so we can just follow this cord, and it comes into our amplifier circuit, right? Our preamplifier. So this is our voltage out, right? That's coming from our speaker here. Oh, sorry, from our microphone. My mistake. Our microphone here on the left. Now, the other component to this is channel 2, right, which is reading from our wave generator. And because the wave generator right here has our out to our amplifier and our in, right, into our box to record it, we'll be able to know what it's sending out and what it's bringing in. So let's take a look and see what we're getting. All we do here on LabVIEW is we hit play. That'll record a second of data, and then we'll go here to my MATLAB program and we'll just update it to the next file so we get what we recorded here. Hit run, and we should pop up a figure of our data. Okay, great. Looks good. We've got our pulse signal, right? That's from our wave generator, from our speaker. And it's going like this. And then if you look at this red here, I've scaled it up bigger down here so you can see on this positive edge, right, of the speaker pulse, we get a very clear reading from the microphone. In other words, it's detecting that wave pressure, and on the negative end it's also detecting that from our speaker. Great. Now let's compare that to what we get when we turn off the output here. So we got no beeping anymore, and this is just to kind of verify that we're actually picking something up. And we want to hit run here on our LabVIEW. Okay, we've recorded another segment of data, update the file, hit run. Okay, so we've got our pulse doing nothing, right? No speaker generation, and then we just have a little bit of noise here at 2.5 volts, which shows that, you know, the system's working. It's picking up that pressure wave. So there we have it. Future engineers of America, we have a sonar device. Granted, it's only working right now at about 4 inches, but with an improved pressure transducer, we could get a working system. The mic is working great. Thanks, everyone.